Hello, everyone. This subject is talking about the elasticity and the solid mechanics. This subject is the introduction of solid mechanics and the elasticity theory. At first, we need to know the mathematics behind the solid mechanics. It includes the basic tensor concepts. So we will talk about tensor, this concept. So just like sigma 1, 1, sigma 1, 2, sigma 1, 3, sigma 2, 2, sigma 2, 3, and sigma 3, 3. So this is a stress tensor. For example, we will talk about it later. And we will talk about the Cartesian tensor. The first, we will talk about the Cartesian coordinate tensors. And then we talk about the curved linear coordinates, like a cylindrical coordinates. And spherical coordinates. These are two main curved linear coordinates transformed by the rotational matrix multiplied with Cartesian tensors. So, and then the chapter 2 is talking about the deformation and the deflections relation with strength. For example, like epsilon ij is a strength tensor. Then it equals half of ui comma j at uj comma I. It's a very important concept. We can use a strength tensor to calculate like the volume variation. Volume variation, like an infinitesimal element. It equals epsilon 1, 1 at epsilon 2, 2, epsilon 3, 3. All of these are principal strength, and the delta V equals the infinitesimal element deformation. Now this direction will be the delta x. This direction is delta y, and this is delta z. When the infinitesimal element expanded to this form, the variation of volume divided by the original volume will equal principal strength, the summary principal strength. In chapter 3, we will talk about the stress and equilibrium. So what's the relation between stress and strength? What's the relation? The relation is Cijkl. It's called the stiffness first order tensor. We will talk about it later in the chapter 4. It will be divided like the isotropic material and anisotropic. Anisotropic material. Before we talk about the stiffness tensor, we evaluate the stress equilibrium. So what is stress equilibrium? There are two kinds of stress equilibrium, like a Cij, comma j equals 0, and Cij, comma j equals rho dot u I double dot. The first Cij dot, comma j equals 0 is the static loading. For example, like a tensor test. When we are doing this kind test, it's a static loading. And when we talk about the Cij, comma j equals rho dot ui dot dot, it's a vibration. It's a vibration and wave propagation. Like I use a guitar. We are playing guitar, and it's one of the string of guitar. When it's deformation, the wavelength energy will propagate from the beginning to the end, and then it's a wave propagation. We will use this kind of equation to describe this deflection behavior. And in this subject, is the information and the concepts are based on the elasticity theory applications and the numerics made by STAT. And another one is the vector and tensor calculation referred to the engineering mathematics made by Han-Xiong Wu. So all of this, we will talk about all of these concepts in this semester. Thank you for everyone.